Hello and welcome to another case study of Net2Plan. Throughout this video, you will learn how to code and execute algorithms for the offline network design tool of Net2Plan. Algorithm execution allows the user to change and manipulate completely any network design. With algorithms, you can create routes, protection segments, SRGs, or even create new nodes and links. First of all, open Net2Plan, then click on Tools, Offline Network Design. If you want more information about how to use the Offline Network Design tool, please watch the video Case Study Offline Network Design. In this video, we will focus on the algorithm execution feature. Net2Plan allows the execution of algorithms coded in Java language. As I said before, these algorithms allow users to perform many tasks in Net2Plan, like creating routes in a topology, protection segments, creating SRGs, setting the capacities of the links of a network, or even creating new topologies with nodes and links from scratch. For this example, we will execute an algorithm that creates routes for a topology that already has nodes, links, and demands. So first of all, we will load a topology. We will use one of the topologies that are included in Net2Plan as examples. In this case, we'll use the example 7 nodes. And as you can see here on the one panel, traffic demand set is not defined. That is because we must also load a set of demands in order to use this particular algorithm. Once the topology and the demands have been loaded, we'll proceed to the Algorithm Execution tab. Net2Plan includes several algorithms as examples, and since Net2Plan is open source, you can download it at any time from the website and review the source code or even modify it if you want. For this example, we will use the algorithm called CFA shortest path fixed utilization. Once you select an algorithm, you can see on this little panel a brief description about what the algorithm does. In this case, this algorithm routes the traffic according to the shortest path and then fixes the link capacities to match a given congestion figure. Below this panel, you can see the parameters panel. Any input parameters that the algorithm may have are located here. You can see the name of the parameter, its value, and a brief description. For example, the parameter called CG, it's the fixed link utilization. If you want to change any of the values, just double click on it and type a new value. For example, we will set it to 0.8. Now, we will just click on the execute button and you can see a pop-up dialog that says the algorithm executed successfully. We'll just click on OK. And as you can see now in the warnings panel, the design is successfully completed. That is, now the design of our network includes nodes, links, a set of demands, and the routes that carry such traffic. If you go now to the Edit Network Plan tab under the Routes subtab, you can see now that a route has been created to carry the traffic of each one of the demands of the network. The next step of this video, we will proceed to download the source code of the algorithm that we have just executed, and then we will perform some modifications to the code to add new features. To do such modifications, we will use the IDE Eclipse for Java developing, because it's one of the most known tools for coding in Java, and also because it's open source and free to download. Once we have opened Eclipse, we will click here, and then we will create a new Java project. And we will name it, for example, OND algorithms. It's important to note that in order to properly code, compile, and execute algorithms in Net2Plan, you must have installed Java SDK 1.7. Once we have named our project, we will just click on Finish, and there we have it. The next process is go to the website net2plan.com. Once the website is open, we will go to Code repository. Here you can find the source code of all the algorithms that are included in Net2Plan. You can even download the source code of Net2Plan itself. So we will go to Offline Network Design and click the Algorithms section. Here you can see the name of the algorithm, where you can download the file and a brief description of each algorithm. So we will just locate the CFA, shortest path fixed utilization, then right click on it and we'll save it. We'll save it on the project folder of Eclipse under the SRC subfolder. Just double click and click on Save. Back to Eclipse, we will just click on our project folder, right click, and hit refresh. And we can see that the file has been included. At first, you can appreciate that there are several errors. That is normal at first. That is because all the external libraries that Net2Plan uses have not been included to the Eclipse project. It can be easily fixed just by right-clicking here, selecting Build Path, then Configure Build Path. Then, when this window is open, click on Add External Jars, locate your Net2Plan folder installation, and click on the lib subfolder, and select all the files .jar that are inside. Just click Open, and then click OK. As you can see here, all the errors have disappeared but one. This is because we have not included the source code file under the appropriate package. Right? We can just delete and remove this line here. We click on Save, and no errors are appearing now. I will proceed now to explain how the algorithm works and how it's coded. As you can see, the file contains only one class called CFA shortest path fixed utilization, which implements the iAlgorithm interface. To better understand the code of Net2Plan, we recommend that you open the Javadoc that is included with every Net2Plan installation. To do so, locate your Net2Plan installation folder, open the Javadoc subfolder, and then the file called index.html. This will open the Javadoc. We will locate now the iAlgorithm. This interface must be implemented by every algorithm to be executed on the Offline Network Design tool. This interface contains only three methods. The first one, called getDescription, it returns a string containing a brief description about the algorithm. The next one, called getParameters, will return a list with all the input parameters of the algorithm. These parameters may be modified by the user before its execution. And the third method, the most important one, called executeAlgorithm, will be invoked when the user presses the execute button. Back to Eclipse, I will proceed now to review the code. As I said before, the method getDescription will return a string containing a brief description or instructions about the algorithm. This string will be then shown on Net2Plan on the algorithm execution tab, as you can see here in this little panel. The next method, called getParameters, will return a list of triple objects. A triple is a set of 3 different objects, in this case 3 strings, containing the input parameters of the algorithm. As you can see, the first string is the name of the parameter. The second string contains the default value for this parameter, and the third string contains a brief description of such parameter. As this algorithm contains 2 input parameters, 2 triple objects are then created, included on the list object, and then returned, so Net2Plan can display them in the algorithm execution tab, as you can see here. Under the parameters panel, when the users modify them, the modified values are then returned upon the execution of the algorithm. And the third method, the most important one, the execute algorithm. It has several input parameters. The first one is a Net2Plan object. The class Net2Plan encapsulates a complete topology. It can contain all the elements of a topology, for example nodes, links, demands, routes, and protection segments. In this case, the Net2Plan object represents the complete topology that is loaded at that moment in Net2Plan. In this case, the Net2Plan object will contain this topology, including all the nodes and links, and the demands that are already loaded. The next parameter is called algorithm parameters. These are the input parameters that may have been modified by the user. Those parameters that are displayed in the parameters panel under the algorithm execution tab are then passed as a map object containing 2 strings. The first string is the name of the parameter, and the second one is the value of such parameter. This value may have been modified by the users. And the third input parameter of the method execute algorithm is called Net2Plan parameters. This again is an input parameter encapsulated in a map of strings containing the global options of Net2Plan. If you want to see the global options of Net2Plan, just click on File, then Options. Here you see all the options of Net2Plan. Since we won't use them for this example, they will remain untouched. Before explaining the rest of the code, I recommend that you take some time to examine the Javadoc of the Net2Plan class. As all the topology is encapsulated in one object, Net2Plan offers many methods that can be useful to the user. For example, the Net2Plan class allows the user to manipulate completely a topology. For example, you can add demands, add links, add nodes, add SRGs, add routes, protection segments. You can extract the demands, get particular routes, and well, you can manipulate the topology at any level that you want. Back to the code. As you can see here, the algorithm first extracts the number of nodes, the number of links, and the number of demands. That is because the algorithm has the purpose to create new routes for the topology. Such topology must have a nodes, a link, of demands. So if any one of these variables is 0, then a Net2Plan exception will be thrown. All the Net2Plan exceptions will be shown as a dialog error in Net2Plan, informing the user that an error has occurred. That is important to note that only the Net2Plan exception will be shown as a dialog error. The rest of the exceptions that may occur inside this algorithm will be shown on the Java console. Allow me to show you. If you open Net2Plan, select the algorithm CFA shortest path fixed utilization and try to execute it without a topology loaded, as you can see, the Net2Plan exception containing this string will be shown here as an error. If another error occurs and another exception is thrown, it will be shown here on the file, show Java console, and will be displayed here. It's important to note if you want to debug properly your algorithm. Next, the parameter CG is extracted from the algorithm parameters map object, and then the shortest path type is also extracted. As you can see, it checks if the CG has an appropriate value between 0 and 1, and again, the value is invalid, it will show a Net2Plan exception. The same check done with the shortest path type, because only two values are valid, km or hops. The cost of each link for computing is calculated. If the of shortest path type is hops, it just will create an array of doubles containing just ones, because the cost of each will be 1. If not, it will compute all the lengths in kilometers, extracting from the Net2Plan object, given the getLink length in kilometers vector method. The next important thing that this algorithm does is it removes all the previous routes that may be present in the network. That is very important, because if we add new routes without removing the previous ones, we may have duplicate routes. So first of all, before creating new ones, it removes all the previous routes of the topology. Then it will get a matrix with a link table. This array will contain several rows, and each row will contain the origin and destination node of that particular ID link. Then it will perform a for loop, analyzing each one of the demands of the network, and for each demand it will extract the ingress node, the egress node, and using the graphutils class it will get the shortest path links between these two nodes. The graphutils class is a very useful particular one, because it contains many methods to calculate routes between between nodes. Once a particular path has been obtained from the ingress node and the egress node, it will be returned as an array of ints containing the sequence of links from the origin to the destination node. Then it will check if this particular array has a length different from 0. If then, that route will be added to the topology. Once this process has been made to all the demands of the network, it will proceed to fix the new capacities of the topology. For that, it will get an array containing all the carried traffic, the total carried traffic by each one of the links, and it will divide such value by the fixed station figure, CG, and then fixing all the capacities of all the links of the network. Then at last it will return a simple string that will be displayed in the dialog, confirming that the algorithm has executed successfully. Before doing any modification, it's advisable to change the name of the class to avoid any confusion with the original one. So we'll just right click on the class, refactor, and we will rename it to the same name, dash modified. We will just click on finish, and that's it. Now I will pause the video and perform some modifications. I have modified the algorithm so it has a new feature. Instead of just obtaining a route for each demand of the network, now it will obtain two paths, different disjoint paths for each one of these demands, and one path will be added as a root and the other path will be added as a protection segment for such root. So now the topology will have a root for each one of the demands and a backup root as a protection segment for each one of the demands of the network. So the initial check-ins remains the same. You may see here that I have added several system.out.println. This can be quite useful if you want to debug and check how your algorithm is executing. All these prints will be shown on the Java console, the same place where any errors in the form of exceptions is also shown, as I said before, except the Net2Plan exception that I remind you that is shown as a pop-up error. So this, when the algorithm is executed, will be shown in the console. We will see this later. I have added some traces here to see how the algorithm is executed. The particular changes are inside here. First of all, it removes all the roots as before, but it also removes all the protection segments that may be present in the topology. Then the method to obtain the two paths that I have mentioned before is located also in the GraphUtils class, and it's called getToLinkDisjoint path. Given an origin node ID and a destination node ID on the link table of the topology, it will try to obtain two different disjoint paths from the origin node to the destination node. Once we check that in fact it has obtained those two paths, the first one will be added as a root and the second one will be added as a protection segment. Once it has been added as a protection segment to the network, we must specify which root it's backing up. We can do it by specifying with this method from the Net2Plan object add protection segment to root backup segment list and passing the parameters the identification number of the root and the protection segment. Also, I have also added here some prints to see how the roots and protection segment have generated. And then for last, fixing the new capacities of the network. It's important to note that since now each link will have a reserved bandwidth for protection, we must include this number at the moment of calculating the new capacities for each one of the links. So we will add the reserved bandwidth to the carried traffic and then divide it by the CG parameter, the fixed utilization parameter. Then, when all the capacities have been fixed, a new string is generated here and then returned to the application. Once all the changes of the code have been made, remind to click on save, and Eclipse will automatically compile the code. And once we have the code, we will go back to Net2Plan. Back again in Net2Plan. To load our new modify algorithm, we'll just click here on load, and we will locate our folder of the Eclipse project, and under the bin subfolder we will just click on our .class file. We'll just click on open, and as we can see here, our new algorithm with its new description, it's been loaded. So we will let all the parameters untouched, and if we click on execute, we can see here that the algorithm has executed successfully, and the exit message is the new one that we have added. We click on OK. Now we will click on File, Show Java Console, and we can see here all the system.out out.println that we have added. You can see here that first of all, executing algorithm, it has performed some basic checks, and all the prints inside the for loop of each one of the demands, it had generated a root and the protection segment for of the 41 demands of the network, and then it had fixed the capacities of all the links of the network. If we go to edit network plan, we can see that in fact it has generated some roots, but it had also generated protection segments for each one of the roots, as we can see here. We can see by this number all the roots that it's back in this protection segment, and then the identification number of such root. We can see that each protection segment is backing up one root, and all the roots are backed up. And that's all. Thanks for watching, and visit net2plan.com.